Forever 21 Rockstars. So, I'm so excited to hold this study session with you today. As you know, we have a pretty big rocks, minerals, earth layers, earth movements, plate tectonics assessment coming up on Tuesday. And this study video is here to help you. Now, I'm going to have these available for you all year long. And the major purpose of these videos, we had one for oceans a while back, is for you to find ways that help you to study at home. Because when I say go home and study, sometimes you might not know what that means, or an effective way to help you study. So I'm going to present you with tons of different strategies that you can use at home, some of them that I used when I was in college. See what works for you, practice, study, get everything together. So a few things that you might need handy as we go through this study session would include pen, pencil, marker, just some paper. If you do not have just plain paper, you can get some from me at school, or you can write on the back of a pizza box, on cardboard, anything as long as you're not writing on the wall. Okay, and some other things you might want to have would, number one, be your interactive notebook, and also your textbook. I have my textbooks here. You may want to also have your textbooks available to help you study as we go along. So, the first major thing that I just want to make sure we all have down is the age of the Earth. Way back at the beginning of this unit, I had you guys predict the age of planet Earth and I presented evidence to you that scientists have used to create that age. That age was 4.6 billion years old. So scientists believe Earth is 4.6 billion years old. Now, we can question and wonder why that is, but the scientific evidence is behind Pangea. And inside of your notebook, you have your Pangea cards. Do you guys remember way at the beginning of this unit when we took the pieces of the Earth and we put them together and we found out that they're really like a puzzle? If I take Africa and then I take South America, which I think I dropped on the floor, just give me 1 second. There it is. And I put those together, I realized that those actually kind of fit. Okay, and then we looked at these areas here and realized that fossils that were found here were also found right here. And mountain ranges that were found here were also found in parts of North America. And the climate today would not allow for those animals to have lived that long ago. So the theory of Pangea was born. And it was from this man named Alfred Wegener. Okay, remember that should be in your notebook. So this is my crude drawing of Pangea. Not very good, but just to kind of get the point across. Pretend this is North America, South America. And these little circles here, guys, are actually the fossils. So they found the same creature lived here that lived here. Okay, and that was really important. A lot of people thought that Alfred Wegener was kind of crazy for coming up with this idea, but as soon as he started presenting the evidence, then people really couldn't say anything. So remember, his name was Alfred Wegener, and he came up with the theory of... Do you guys remember what it was as I'm writing it down? It's the theory of continental drift. Okay? And think about the word drift. If something drifts, it just kind of slides along. Now, this took millions of years to occur. Excuse me, guys. But Alfred Wegener came up with the theory of continental drift. What I want you to do is take a little bit of time to just kind of conceptualize all that. Take all of that information, write it down in some form. Draw a picture, write a few sentences. Something to just kind of help you to understand everything, all the evidence that was presented. The age of the Earth, 4.6 billion years old, okay? And the fact that Alfred Wegener proposed this theory of continental drift that basically said we used to have this gigantic supercontinent, and slowly, as the plates broke apart and they moved, okay, we have the world that we know today. So just take a little bit of time. You can pause the video here, write down some things to help you to remember that. Draw a picture, whatever happens. But the major terms that you need to know here was like the light bulb, Pangea, Alfred Wegener, and theory of continental drift. It's actually pretty astounding and pretty amazing if you guys honestly think about it. Okay, so we have some Pangea action. Think about what Alfred Wegener's conclusion would be with continental drift. He basically concluded, okay, if you've written it down now, that the Earth used to be one gigantic supercontinent, and slowly it broke apart. Now, way back a couple weeks ago, I had you guys peel an orange, and I just said, hey, peel it in as many pieces as you want, okay? And then I made you guys put it back together with toothpicks. Now, I have no oranges at home right now. Not a real big orange fan, but I do have another thing from my fridge, and that would be an egg. Okay, now I'm going to be very gentle with the egg because I do not want the egg to break. But maybe something else round that you may have at home, including an apple, an orange, anything like that. The shell of this egg, okay, the part that cracks, would represent the crust of the Earth, correct? Yeah, so we have the crust of the Earth. Okay, and that's broken into these plates. Now, before we go any further, I do want us to think about the layers of the Earth. Okay, so I want you just to grab a sheet of paper, and I want you to draw a cross-section of the Earth. What does that mean? Well, let me show you. It's going to kind of look like a piece of pizza. Here's my cross-section of the Earth. So pretend like, the Earth is kind of a cake, and I took this piece out. Up here we have this layer, then we have these 3 layers here. Okay. Now I really want us to practice labeling the 3 layers. That's one thing, but also knowing what is composed of each layer. That's a very important thing that we also have to have down. So take a few moments right now after you've drawn your cross section of the Earth to label the 4 layers of the Earth. Think about the song. Throw your hands up for the layers of the Earth. You guys remember that one? Throw them up for what's below the surface. Throw your hands up for the layers of the Earth. Inner core, outer core, mantle, and crust. Okay. Check your work with mine. Right now, I have the inner core, which is that solid ball of metallic materials. Then I have the outer core, the mantle, and the crust. What layer is the thickest layer? Okay, and I didn't do a real good job of drawing it on my diagram, but that would be the mantle. Okay. Now, we have the 4 layers of the Earth down. Now we have to make sure that we know what is composed of, or what each layer is kind of composed of, I guess I should say, which is a very, very important component to make sure we have down. Or the characteristics. So the crust is obviously made of mainly rock, soil, different things like that. It's the thinnest layer. Remember, it's about 25 miles deep. Okay. How about the ocean crust, though? Is it thin or thick? Is it more thick than the crust on the land, or thinner than the crust on the land? Good, yeah, it's thinner in the ocean. The crust is not as deep, but it's still, 25 miles is pretty significant. Human beings have never gotten past the crust in order to get in there and figure out what is there. Now, the mantle is obviously made up of molten rock, magma. Okay, and it's just churning like we've talked about. It's like that melted plastic. Those visuals and those videos and pictures that I showed you, all great, great ways to remember what the mantle is made of. Okay, now the outer core is still kind of melted, but remember, it's kind of melted metal materials. It's kind of, I don't want to say gooey, but, that's kind of a way to think about it. Okay, the Earth's magnetism, the fact that we have north and south poles and our magnets, the magnetic field is actually created from this layer. So a lot of metallic materials, iron, things like that. And finally, the inner core is made up of solid materials, okay? Just totally solid materials, including metal type objects. And think about it, because the pressure and the temperature, okay, but definitely the pressure, the reason the inner core is so solid is because it's just a solid ball, okay? Because think about all the pressure that's pushing down on the inner core, okay? So make sure you know the layers of the Earth, but also know what each of them is made out of. Guys, your science textbook, let me actually open up to a page that might help you there as well. Now remember, this is my teacher's book, but it still has a great, great visual. On page 389, you have your layers of the Earth there. A great way to study. Our mantle is the largest portion of the Earth's interior. Outer core is made of molten metal. Inner core is made of solid iron and nickel. Okay, remember, it's a solid ball. And the crust is a thin, rigid rock layer. That's what we live on, is the crust. Okay, so layers of the Earth, great resource to use in your book as well to help you study. Now that we have the layers of the Earth, okay, pretend that the egg, okay, it needs to be a little more spherical, but pretend that the egg is like the Earth. So the shell is like the crust, right? Okay, and then inside of here we have the yolk, and then the white part, that goes around the yolk. So the yolk is in the center. That would probably be like the outer core, or I'm sorry, the inner core. Okay, that solid ball in the center. And then we would have to take the white part of the egg, okay, the egg whites, and divide it into two, and we have the mantle and the inner core. Okay, so that's a way to think of it. Now, if I took this egg, which I'm not going to do right now because it is not hard boiled, and like I did my orange, and just cracked it, we then know that Earth is divided into these plates. Okay, there are how many major plates that make up the Earth, everyone? 7. Good. So Earth, is like that orange. The crust is not one solid piece. It's broken into these plates, and these plates are constantly moving. Okay, and the reason they are moving is what we are going to talk about next. So take your cross-section diagram one more time. Okay, because in class we talked about why do the plates move. Now right now I just want you to pause the video and think to yourself, back to yourself, why in the world are the plates, okay, the crust is broken into these big plate tectonics, why are they moving? So pause the video and just ponder that right now. Why are the plates moving? Think about the key vocabulary that we talked about as well. And I'm going to challenge you right now. I'm going to give you some words. So think about that as I write down a few words to help you. Okay, guys, my challenge to you right this minute is to take these 4 major words and write them into some type of explanation, because this explains how the plates move. We have convection currents, thermal energy, mantle, and plate tectonics. So pause the video, try to put those together, or draw a diagram and use these as your labels to try to think about why do the plates move. So I'm just going to move this in, pause the video, and try to explain why the plates move. Okay, guys, so here's what I came up with as to why the plates move. Okay, so here's my cross-section diagram of the Earth. Okay, all of this activity is taking place in the mantle because we know that the mantle is made of this molten magma. It's like this plastic that's just churning. It's so hot, 4,000 degrees Fahrenheit. Okay, we talked about how incredibly hot that is. It's really hard to imagine how hot that is because, today it's 65 degrees Fahrenheit outside, and if the magma down in the mantle is 4,000 degrees Fahrenheit, think about how incredibly warm that is. That's crazy warm. So inside of the mantle, we have this magma that is churning. And remember, it's called magma when it's in the Earth and lava when it's out of the Earth. So this magma is just churning, okay? And these are called convection currents. Just like we talked about with the ocean, the currents in the ocean, those underwater rivers, this magma is going in circles, kind of, and it's creating what we call these convection currents, okay? Those are created by the thermal energy. Thermal meaning heat. So 4,000 degrees Fahrenheit is producing a lot of heat. And so it's causing that magma to churn in circles. Well, and if you think about it, if the whole mantle is churning, it's almost like the crust and the plates are kind of floating on top of the mantle, but not really. And so they're moving. And sometimes the plates slide past one another, and sometimes they go into one another, and sometimes they pull apart from each other. So the crust of the Earth, like we talked about, those plate tectonics are constantly being affected by all of those factors, okay? So these are the terms that you need to make sure you have down and that you're able to articulate into something that you could possibly write out. And make sure you also know the difference between the magma and lava. Okay, so that is why the plates move. Now let's talk about the 3 different types of plate boundaries. So what I want you to do with your sheet of paper right now, and let me just get myself organized a little bit. Now, in your science interactive notebook, guys, we put in a bag this diagram that said plate tectonics, convergent, divergent, transform. These are our 3 types of boundaries, right? So I would lay this out right now. Pause. Lay this out, take everything out of the bag, and just sort them. So take those cards that are in your bag and try to see if you can sort, this picture would show the plates sliding past one another, striking and slipping. That's a transform boundary. Okay, these are formed when plates slide past one another. Once again, transform boundary. Also known as strike, slip, or sliding boundaries, transform boundary. Mid-ocean ridges are created by these plate boundaries. Those are divergent, good. Then we have ocean trenches are created by these plate boundaries. So continuously, just put those out, sort those out. Now, if you need some answers or ways to help you, we talked about on page 388 were the layers of the Earth. Well, if we go to the next page, 390, 391, we're actually, number 1, going to look at those major plates. So we talked about the 7 major plates. Okay, how is Earth created into those? And then if you go to 393, this is a great key for you guys. You have the 3 different plate boundaries with the images, and it shows you what's created here. So when 2 plates pull away from each other on land, this forms a rift or separation. Okay, it eventually becomes 2 separate land masses. So that would create a trench in the middle of the ocean. Okay, and then when 2 plates slide past one another, you get earthquakes. And when 2... Okay, guys, so let's continue with our study of those major plates. So after you have sorted all of your cards, okay, check those out there. What I want you to do actually with just a sheet of paper is to simply divide that into thirds. Okay, step number 1. So I'm going to divide my paper into thirds like this. Across the top, I'm going to put the labels of the 3 major boundaries, which would include convergent, divergent, and my marker's kind of going, and transform. So I divided my paper into thirds, and then I labeled the top. Now, the first thing that I would actually do, and it sounds really simple, but it's a good way to make sure you remember, is show me those boundaries with your hand. So convergent, divergent, and here's a strike, slip, the transform boundary. Okay, so everyone has those down. Then what I would do is practice diagramming those on the paper. So let me show you what I have here. So I actually wrote down, and I'm going to cover this part up right now. Okay, so a convergent boundary, converge means to come together, or sometimes one goes under the other. Then you have divergent when they're going apart, and transform is when they're sliding past one another, the strike-slip boundary. Now, one of the major things that you do need to have down is real-life examples of each of these boundaries, okay? So underneath right now, think of a real-life transform boundary, a real-life divergent boundary, and a real-life convergent boundary. Think about what we talked about in class. We wrote those down. Think about when we had the graham crackers in class way back. That is actually when we were talking about these different things. Here's what I came up with, guys. So my geological features. For the convergent boundary, we have the Rocky Mountains or the Himalaya Mountains over in Asia. Okay? Remember, convergent, the plates are coming together, and you get that creation. The Mid-Atlantic Ridge, out in the middle of the Atlantic Ocean, remember we said some of the tallest mountain ranges in the world are there, would be an example of a divergent boundary. Now, why is that? Because the plates are moving apart. And think about what we talked about. If the plates totally move apart from one another, well, what is exposed? You have the mantle that just kind of comes up, because that mantle and that churning lava, the convection currents are just waiting to spill up. So they have formed different things. So new crust is definitely formed at a place like the Mid-Atlantic Ridge. And then your transform boundary, your strike-slip boundary, remember they're called strike-slip because they just kind of, and pressure builds up. Yes, they cause earthquakes, but to be specific would be the San Andreas Fault, which we talked about out in California. Okay, that's the fault line where the 2 plates are cracked. That fault, that's where the major earthquakes occur. So you do want to make sure that you have all of those items down. Okay, guys? Now that really takes us to the end of the Earth movements, plate tectonics, all of that part of the review. So, one of the major things that I would just look at is in your book, and let me direct you to that page. Well, really starting there's some really great review in here, guys, if you really just flip through. Starting on page 400, let me pull this up here. You know, you have some different summing up activities. You have kind of a diagram type review. Now, the cool thing that I think they have available in here is actually the review at the end. Starting on page 407, this is the Unit 8 review. Now, you do have to remember, like we talked about in class, your science book has some things that we're not studying this year, so some of the questions you are going to have to skip over. But some of these questions are excellent, guys, for you to review. If you complete this science review test in here, you can get yourself 3 house points, okay, for that. Now we're going to transition quickly over into rocks and minerals, okay? So that's the second part of the review that we have going on right now. Now, talking about rocks and minerals, the first major thing I want to talk about is, well, what is a mineral? Okay, we tried to grow those crystal minerals. What is a mineral, guys? Think about that. Yeah, well, it forms underground. It's naturally formed underground, and it creates these crystals. So we're able to distinguish minerals apart from one another simply based on their crystal structure. Okay, and remember, way back we talked about the different structures that minerals could possibly have. Now, here's a part that I want you to look at pretty closely. So with minerals, last week when the aliens touched down at Cape Waller Barrett, we went out and found their samples that they had outside, and we talked about a couple of the properties of minerals that we use to help us identify them. Okay, so those properties included color, luster, streak, hardness, and cleavage. Okay. Now, it's very important that we know each of these. So color is pretty straightforward. I look at a mineral, I determine its color. Luster is the shine that it has. Is it a glassy luster? Is it a metallic luster, very shiny? Is it earthy? Does it kind of look like the earth? Streak, remember we took those white streak plates and we took the mineral and tried to determine what color of streak it left. Then we had hardness, and that's where we talked about the Mohs hardness scale, guys. And you can either find your minerals on a scale of 1 to 10. So a mineral of 1 would be talc, very soft, basically can crumble apart. And the hardest mineral out there is actually a diamond at the number 10. Okay? And remember, there are different ways that we could use to determine the hardness. We used pennies, we used nails, and we simply used our finger to see if it could scratch it. Okay, to find the hardness. And remember, cleavage is simply taking a rock and seeing if it breaks into flat sheets. Okay, if the rock breaks into flat sheets, then it has a cleavage. So these are the properties that we use to measure and identify minerals. Make sure you have those down. That would be a great review, okay, that you might want to look at home. We do not taste minerals, okay, that's not one of the properties. These are our properties. Now, when we take minerals and we put them together, we have rock. Okay, solid, it's made of sediments, and it's formed naturally. Okay, so when we take our minerals and we put them together, rocks are formed of different minerals simply brought together. Now we have our 3 types of rocks, and like I'm going to show you guys in a little bit, there are some amazing links and resources that you can use to study from on our Class Fusion page for the different types of rocks. Something that I would pull out right now would be that rock study guide that I gave you guys to look at with those cards. Okay, and once again, sort. If you do not have those cards at home right now, well, another strategy that I would use is I would simply, once again, and you could actually take the paper that you divided into thirds the first time, okay, and on the back of that, I would just write the 3 types of rocks. We have sedimentary, we have metamorphic, and we have igneous. Okay, so if you take those 3 types of rocks, you need to know how each of these are formed. So those cards that you have that are in your Science Interactive notebook, great way to study. Think about the crayon experiment we had, okay? That would be excellent as well. You know, I have, this is what my study sheet would look like, you know. Take some time, pause with that, write down how each of those rocks are formed, maybe some real-life examples. Use the sort that we have in your Science Interactive notebook. But then, here is what I would have had, guys. So under sedimentary, sedimentary rocks are formed from weathering and erosion. It's when the sediments compact and cement. Compact and cement are very important words here. Okay, igneous rocks form when lava and magma cools and hardens, and it's from the process of melting. Normally, typically in the mantle. Remember, we talked about a lot of igneous rock forms in the mantle. Think about when I melted that pot of crayons, which was a mess, and then I took it and I poured it into that water, and it instantly became rock. That was an example of igneous rock. And then we have metamorphic rock. That's when we have our heat and pressure. Okay, that's when I took the iron and put it on top of the crayons and just kind of pressed down. It's not that the rock melts in that stage, but it just kind of compacts together because of the heat and the pressure. Most metamorphic rock is formed underground, obviously. Okay, so those are the three types of rocks that we need to have down. Now, you know, the biggest thing is, okay, well, the rock cycle. Here's how you can quiz yourself on the rock cycle, guys. Simply ask yourself, choose two types of rock. How does a sedimentary rock get to an igneous type of rock? Because we know that all types of rock can become other types of rock if their conditions are correct. So ask yourself, how does a sedimentary rock form into an igneous rock? Okay, so I have this rock that's formed out of sediments. How does it become an igneous rock? Well, that sedimentary rock has to make it into the mantle. It has to melt, and then it would have to either erupt from a volcano, that magma that then becomes lava, or it forms in those pockets underground, and that magma would have to cool and harden, and we would have an igneous rock. Okay, here I have one for you guys. How does an igneous rock become a metamorphic rock? Good, yes. So it would obviously have to make its way through the crust of the earth with heat and pressure. Okay, when that melted magma filled rock, heat and pressure comes together, you would get a metamorphic rock. How does a metamorphic rock turn into a sedimentary rock? Good, yes, so we have our metamorphic rock, and it's raining, there's wind, there's all of this stuff going on, and then the sediments break off from the weathering, and then we get ourselves a sedimentary rock as soon as it compacts and cements together. So kind of go back and forth in your mind with each of those guys, and ask yourself, how does each become the other? You know, you can check out in your book, I think the best diagram is actually on page 435 for you guys. You looked at it with your reading guide, which is another great study tool that I would use. The three types of rock, and all of these lines are going in different directions. You know, these show you how one type of rock can become another type of rock pretty instantaneously. Okay, so those are all there. Another great study tool. Okay, so we've talked about the types of rock. We talked about the rock cycle. In a little bit in the study video, I'm going to take you over to my computer screen, and I have an amazing, amazing site that you guys should really check out to check out the rock cycle and the different parts of it. And it's once again animated, so it kind of shows you how one type of rock becomes another type of rock, and what does weathering look like? What does heat and pressure look like to create a metamorphic rock? How is a sedimentary rock formed? An amazing site. Check it out. Okay, the last thing that I really just want to, touch base on with you guys really quickly, and we kind of talk about it with the rock cycle. That's why I don't think we have to spend too much time on it, but that would be weathering and erosion and deposition. Okay, those three terms, as you know, we've been talking about for a while now. Let me actually write them down on paper. So we have weathering, we have erosion, and we have deposition. Okay, and I guess the other term that I would throw in there would be sediment, that we also defined. So once again, maybe just jot these down on a sheet of paper. Okay, think about some real-life examples of weathering, erosion, deposition, and sediment. Okay, the number one thing I would think of that always comes to mind is a waterfall. Okay, so I'm going to draw a waterfall. Now bear with me, because we all know Mr. Reichert is not an artist. Last week's vodcast kind of did this for you guys, which I thought was cool. But here we have a waterfall, okay? Now, the green, or the bluish aqua, is water, okay? Now, as that water continues flowing over, this is all rock here, okay? Continues flowing over, it's actually breaking down that rock, and what we get is, we get pieces of sediment, okay? So, all these black chunks here are sediments. Okay, these are all floating down because that water's going over and over and over. And maybe a crack formed here, okay? and maybe the water got into it when it became winter, and it began to crack the rock, actually, okay, and maybe chunks of that rock fell off. So all of that is considered weathering, okay, the breaking down of rock from some kind of natural force. So here we have weathering, sediments break off. Well, erosion is simply the carrying of sediments from one place to another. So okay, Room 21 Rockstar, so some online resources that you may want to use to study for the rock unit. I put them all together. Pretty cool, some of these. So I'm going to take you down the page, and if you actually go under the Science Study folder, under the Rockstar Documents, I put together this guide, and there are a ton of different links here that you can actually visit. The first one is an awesome rock cycle interactive site. And the reason I say that is because, you know, if there are still a few things cloudy about the rock cycle, and I hope it's taking us there, this really helps to explain that for you. It not only explains the types of rocks, but it also explains how they're formed. So, you know, here's how an igneous rock turns into a metamorphic rock through all that heat and pressure that I showed you. And then select an animation. Here is how metamorphic rock turns into magma. Once it gets close enough into the mantle, that's exactly what occurs. And then you can show weathering and erosion. The rocks are eroded and washed away by wind and water. See those little chunks just flying. And then you have sediment, and the sediment goes into a water area. And then we get compacting and cementing, which is going to form the sedimentary rocks that we looked at in class. So it's all plopping down. The accumulated sediment is pressed together to form sedimentary rock over time. Look at that right there, guys. This site is just so amazing because it really puts that visual together for you. I absolutely love it. Now, you can also check out the rock cycle diagram, okay, which will help you, you know, do it when it's empty, so it gives you questions, or you can also look at it. Types of rocks are also addressed here. You know, it's not necessary that we know specifically different types of rocks, but I thought it was kind of cool. You know, this is gneiss, okay? It forms from other rocks that have been squeezed and heated for a long period of time, so that would be considered metamorphic rock. Here's some limestone. Limestone has fossils in, and we know that fossils indicate sedimentary rock. Then you have conglomerate. These are just chunks of different rocks. Pebbles, other larger rocks. We also know that that is sedimentary. Kind of cool there as well, I thought. Now, you can click on any of these types of rocks, guys, or choose to click on an animation, and it's going to animate things for you. There's weathering and erosion. You know, magma, it shows melting. How does a rock melt? So anywhere that you might still be confused about how does this rock turn to this rock, amazing site. Okay, just absolutely incredible for anything like that. Now I'm going to take you back to the page. So check that out if you're still a little confused about different elements of the rock cycle. Here's a song I have. You can check it out yourself. Somebody put it together it goes to the tune of Teach Me How to Dougie, but it's Teach Me About Rocks. This site looks a little bit at weathering and erosion. It's called Breaking News, and it kind of takes you through some examples. You do need to know some separate examples of weathering, erosion, and deposition, so that would be a great site to visit if you're still a little confused with that. This is a diagram, this rock cycle interactive diagram that we looked at in class, okay? In my opinion, this one is not as kid-friendly as the one that I just showed you. And finally, the Earth's Layers game, I thought this was kind of cool. Just check it out. It's your job to study the diagram, and obviously we're working with layers of the Earth, but, you know, and then they test you on that after you have studied that. So these are some resources that you guys can use to study rocks, the rock cycle, all of that good stuff at home. There are still a few things left that I put here. Number one, from way back under the links section, would be SOL Pass, guys. If you click into SOL Pass, okay, and then you choose 5.7, which is Earth, what we just studied, you can not only get a study guide of everything that we've studied, you can practice release questions, you can play these different games, you know, rock cycle, drag and drop, just amazing things. Let me show you one, for instance. Okay. And our password is just Tigers. Remember, our password is just tigers. But exposed to extreme heat and pressure below the Earth's surface, any type of rock can turn into metamorphic rock. Okay, and then your beaker is going to fill up with the potion. So now I'm going to turn you over to Mr. Riker. These are just some online resources that you can use at home to help you study.